So now we will try to understand what is allocation of memory. So allocation of memory is a process in which memory will be reserved, means some space in memory will be allocated for variables. That is called allocation of the memory. Whenever variables are created, that moment, so memory location in memory, some memory locations, that is called memory. Okay, some part of memory will be allocated for the variables. So this way to allocate memory depends upon the type of memory. Okay, depend upon type of memory, how many types of memory, static memory is there, dynamic memory is there. Okay, so how much of memory is being allotted, it is depend upon type of memory. So C has how many types of memory, static memory, dynamic memory. Depend upon that memory, how much of space to be allocated, it is to entirely depend upon type of memory. Static memory, so static memory, first of all we need to understand what is static memory is a memory, so it is reserved for variables before the program runs. Okay, so in the previous classes I have briefed that what is run. Run means execution, otherwise compilation. Both two terms I have explained, compilation and run. Run means also execution. So static memory, this memory reserved for variables before program runs, before the execution of the program. I told you that execution, what is compilation? I told you that compilation means converting that source code into object code, means binary code 0 comma 1. Okay, first of all what happened, compiler will check for errors. If there is no any errors, means bugs, and that code will be converted into machine language, that is compilation. But that code will not be executed. In the compilation only the source code will be converted into machine language 0 comma 1. Runtime, run means execution time. What happened, this 0 comma 1 binary language bits, okay, they will be sent to microprocessor understand that, and it will give the result in human understandable format. That is called execution means microprocessor understands that 0 comma 1 machine language, and then it will give again the output that can be understand by humans. Okay, that is called execution. So static memory is that memory which is allocated for variables before the program runs. Okay, allocation of static memory is also known as compile time memory allocation. I told you that compilation is why I told you that compilation, conversion of source code into object code, means binary language 0 comma 1, that is called compilation. So at that compilation time, whatever the memory will be allocated, that is called static memory. Okay, compilation time, you need to, as a programmer, to understand these two terms, compilation time and execution time also called runtime. Okay, so runtime and execution time is what, that 0 comma 1 machine language will be fed to microprocessor, so that microprocessor can understand that machine language and it gives results. That result is in the form of human understandable language, English like language again. Okay, so allocation of static memory is also known as compile time memory allocation. So C automatically allocates memory for every variable when the program is compiled. So at the time of program compilation, at the time of program means sequence of instructions, at the time of compilation, C automatically allocates this static memory for every variable. So whatever the variables you have created, so for that variable somewhat memory space to be allocated, that is done by C compiler at the time of your program compilation. For example, if you create an integer array already I told you the array is what, so many memory elements. If variable created, if you want to store many elements in a variable, it is not feasible. So we will create an array, and that array will be able to store multiple elements, same category in C language. So array of 20 students are there. 20 students means it is in 20 students. What type of data we are allocating for the 20 students means 20 elements. It is a student array. So that is integer array. Already clearly stating that if I want to create an integer array of 20 students, okay, these 20 students are 20 elements. So every student, how much of type of data to be allocated for integer? Integer means already we have stated that it is an integer variable, okay, integer array. So that every student integer 4 bytes of memory. So 20 into 4, 80 bytes of memory to be allocated for this array of integer array of 20 students. Because in the previous classes we have studied that for integer 4 bytes, for float 4 bytes, for double float 8 bytes, for char 1 byte, for boolean type of data 1 byte. So as per that, if any integer array, if it is not array, it is only one variable, integer variable, so 4 bytes of memory will be allocated. So array means what, I told you that array is the variable created to store multiple elements, same type of multiple element. If it is integer array, it will store many integer elements. So 20 students means 20 students data can be stored in that array. So it is an integer array. Every integer variable holds 4 bytes of memory. So 20 into 4, 80 bytes of memory will be allocated for this integer array. So now try to understand here, students is an array, okay, that is integer data type. Array will be created, array, first of all data type integer, then name of that array, and in square brackets how many elements, for how many students I want to store the data, 20. This is the size of that array, integer array. So now by in the previous class I told you that how to know the size of that size of memory allocated for that. We can simply know that size of operator, okay, and format specifier %lu. So this is the code written to find out that how much of memory allocated. This is what int is students is a array, integer array, and in square brackets compulsory we need to write, because array always will be mentioned in square brackets. Within the square, how many elements we want to store in that students array. So 20 integer elements, so 20 into 4 bytes, 8 bytes. So syntax is that printf in bracket %lu, that is the format specifier. I told you that format specifier will be used to it will help the compiler to know that now compiler is dealing with which type of data. Compiler ready to work with integer type of data. So this format specifier indicates that. So size of operator will be used to know how much of memory will be allotted for that array here. So answer is 80 bytes. If I change this as 30 elements, so ultimately 30 into 4 bytes, so 120 bytes of memory will be allocated for this static memory will be allocated. This static memory, as I told you that allocation of the memory, how much of memory to be allocated, that depend upon type of memory. Suppose if you the memory is being allocated at the time of compilation time, so static memory will be allocated. So at the time of execution time, runtime, dynamic memory will be allocated. So how much of memory will be allocated, that is depend upon your stuff. Whatever the stuff means, how much of variables you are creating. The variable is single variable, otherwise it is a single variable. Otherwise, if you want to store multiple data in a variable, so that moment we need to create the array. So array will be used to store similar type of many elements. Okay, this is the syntax. As I told you that this is the normal syntax, don't worry about that. It's very simple to write that. See, if I want to change this 30 elements, I want to make it double float. What happened? Double float, I told you that double is a data type. Okay, means float, it is a float type of data. Means double means float type, but to store many decimal digits, up to 16 15 decimal digits. So it will be used to store how many? 30 elements. 30 data double float can be stored. So 30, every double float 8 bytes will be allocated. So 8 into 32, 8 into 30 is what? 8 into 30 to 240. 240 bytes of memory will be allocated here. How much? 240. Understood that? It is depend upon your, suppose it is a boolean type of data. So I told you that boolean, so leave it that for boolean. Char means a char type of data, but it is it is not a single variable. It is an array, char array, to store 30 characters. 30 characters to be stored. So every character 1 byte will be allocated. So 30 into what? 30 into 1 byte means 30 bytes will be allocated here. 30 bytes. Okay, so if it is a boolean type, so as I told you that if it is a boolean type of array, boolean data type array, and 30 elements to be stored, 13 elements, boolean elements, true or false. Okay, so but it will give error. Why? Because I told you that whenever you want to work with boolean data type, you need to include one header library, that is called std_bool. So this is the error. So that moment you need to do what? Nothing. You simply you add one include, that is what? Include one library, that is called std_bool. std_bool.h. This is the library, std_bool.h. Okay, now you can work with 30 elements for 30 elements bool data. So every bool data occupies 1 byte. 1 byte of memory will be allocated for one bool data type. Okay, so 30 elements. Okay, to store 30 elements, 30 into 1 byte, 30 bytes. Okay, like that, as I discussed that for integer data type 4 bytes will be allocated. For float, only float type of data, it is a, suppose if it is a float type of data, float, it is a float type of data. Every float type of data, float means all that negative and positive numbers which are having decimal values. Okay, up to float type of data can store up to 5 digits of decimal values. So every float type of data, float variable, 4 bytes of data will be allocated. So 30 into 4, 120 bytes. 120 bytes of the memory will be allocated for this array, float array. Students is a float array to store 30 elements. Okay, understood that? So in this way this is called memory allocation, and that allocation of the memory depend upon your type of memory, static memory and dynamic memory. Static memory will be allocated at the time of compilation time, okay. And so now what happened, suppose 20 students, I want to store the data of 20 students, but whenever the semester going to be terminated, so only 12 students are attending out of 20 students, so 8 students memory is unused here, understand, out of 20 students. So at the time of semester going to be completed, 12 students are remaining attending the classes, and remaining 8 students are unused. So for 8 students, how much of data allotted for 8 students? Every students 4 bytes of memory, 4 into 8 students, 32 bytes of memory is unused. It is wastage of time. So that 8 students memory, 8 into 4 byte, that is to be released. Otherwise that application, that program's performance may be slow, understood. This is called memory management. Why? Because once your array is created, so initially whatever the size, 20 elements size I have mentioned, so we are not able to change the size of the array, so you are left with unnecessary reserved memory. Why? Because once array is created, then after it is difficult to change the size of memory array. For 20 in place of 20, only 12 students, so the changing of size of memory is difficult in C language. We will not be able to change the size of the array, so you are left with that memory, unneeded memory for remaining students, 8 students, that is allocated, okay. So now what happened, program still run. So such a situation, what happened, so program still runs, and that memory, unneeded memory will be like so much of this type of code will be there, okay. So whenever so much of code will be there which is not useful, so ultimately what happens, it will slower the performance, optimization of the program, understood that. It is simple example I am briefing here. Simple exam is what, one array created, that is integer array, students name is students, and initially created for 20 integer to store 20 integer elements. 20, every integer element will hold 4 bytes of memory, so 20 into 4, 80 bytes of memory. But what happened, as the semester going to be terminated, only 12 students are there attending, and 12 students means remaining 8 students are unused students, and their memory allotted 8 into 4 bytes is 32 bytes is the unused memory. So like that in the code, so many such type of instance events may be there, and for that unused events memory will be going to be waste. So whenever unused memory is there, so ultimately what happens, it will slow down the performance of the program. Now you want to control, as a programmer you want to better control of allocated of memory. So that moment we need to check back dynamic memory. As a programmer you want to control, you want to handle the memory allocation. So that moment what happened, if you want to better control of allocated memory, we need to look into that dynamic memory. Okay, dynamic memory is what happened. Dynamic memory, so it is the memory which is allocated so at the time of program running. Okay, dynamic memory, static memory will be allocated at the time of compilation time. Dynamic memory, that is allocated after the program running starting. Okay, execution time of running time, dynamic memory will be allocation of dynamic memory can also be referred to as runtime memory allocation. This type of memory allocation at the time of program executing, program run. I told you that what is run or execution means that machine language, it has so many names. Machine language, binary bits 0 comma 1, these are all are equal. Okay, that moment, so whenever this code will be sent to microprocessor tries to understand that, and then it will give the result in the human understandable form. That is called runtime, otherwise execution. That time of execution time, whatever the memory is being allocated, that is called dynamic memory. Unlike static memory, we have full control over how much of memory is being used at any time. So in dynamic memory allocation, as a programmer, we have the full control. Okay, how much memory that is to be allocated that time. Okay, we have full control over dynamic memory. But at time of static memory, the program has his control is somewhat less. Okay, so we can write the code in such a manner to determine how much of memory that is to be allocated. Okay, how much of memory need, and that memory can be allocated, so we can write the code in dynamic memory allocation time. Okay, dynamic memory, it doesn't belong to a variable, it can only be accessed with pointers. Okay, dynamic memory doesn't belong to a variable. Okay, it can only be accessed, always dynamic memory will be accessed through only pointers. Okay, we have studied in the previous classes what are the pointers. Okay, so pointers are some variables which will hold the memory address of variables. So pointer is a variable, pointer itself, it is a variable, it holds the memory address of another variable. So dynamic memory it doesn't belong to a variable, it will be accessed with the dynamic memory will only be accessed with pointers. To allocate dynamic memory, we can use the malloc or calloc functions. So if I want to allocate the dynamic memory, so at that moment as a programmer, I can use the malloc or calloc functions. That moment, one header file to be used, that is library.h. This is the basic library. Generally this is called suppose at the time of, this is called std input output header file, input stdio.h. so along this also we need to use one more library, that is called std library.h. This header file that is to be included. If you want to work with these malloc and calloc functions, whenever you want to work with dynamic memory allocation, so if you at that moment we need to work with malloc and calloc functions, both are part of your stdlib.h. That is what header file. Okay, this header file to be included. So the malloc and calloc functions allocate some memory and return a pointer to its address. Okay, these malloc and calloc functions they will allocate the memory. So and then it returns a pointer. So pointer, I told you that pointer will store the address. Pointer will have the address of that variable. Okay, pointers. So whenever we use this malloc and calloc functions, they will allocate the memory and returns a pointer. That pointer has the address. Okay, so see here what happened. See in this code, int star ptr1. That star ptr1 is what? Pointer. And one more pointer created, that is pointer name is ptr2. Star means star is the, so whenever we have written star, then whatever we write, that is a pointer. Okay, so int star ptr2 is equal to calloc. Here malloc function, in bracket we have used size, and calloc function amount of amount comma size. Try to understand what happened here. The malloc function, what its role, how does it function? This malloc function, it has a parameter. That parameter is called size. Malloc function has a parameter that is called name size. So how much of memory to be allocated? This size parameter, part of your malloc function, it specifies that how much of memory will be allocated, so measured in bytes. And calloc function, it has two parameters, amount comma size. So amount parameter specifies the amount of items to allocate. Amount of items to allocate. Size means specifies the size of each them measured in bytes. Amount means specifies the amount of items to allocate. How for the memory to be allocated, for how many elements, how many items, how many elements are there, otherwise how many items are there to allocate the memory. Amount parameter will specifies that. Size is what? It specifies the size of, how much of size of memory for each item that is to be allocated in bytes. Okay, so the data in the memory allocated by malloc is unpredictable. The data in the memory allocated by malloc function is unpredictable. To avoid unexpected values, make sure to write something into the memory before reading it. Okay, something we need to write into the memory before reading it. Unlike the malloc, the calloc function writes zeros into all of the allocated memory. So calloc function, what it does, it writes zeros into all of the allocated memory. Initially in that memory it writes zeros. However, this makes calloc slightly less efficient. Calloc, so whenever it writes zeros initially into this memory, so it makes calloc slightly less efficient. So what happened? Malloc function. So the data in the memory allocated by malloc is unpredictable. Why? Because data means I told you that integer, float, bool, character, whatever data, that is the data for that memory allocation by malloc function. Malloc will allocate some memory, na? So within that memory, the data stored in that memory, so that is unpredictable. So to avoid such type of unexpected values, so we need to ensure that we need to write something into the memory before reading it. Okay, so before, if you want to read that, before that you need to write something into that memory. But calloc function, it writes automatically zeros into all of the allocated memory. So that's why calloc slightly less efficient. So what is the best way to allocate the right amount of memory for a data type is to use the size of operator. So already we have studied about that size of operator. By that, how much of right amount of memory for that data type will be allocated. Okay, the way is that size of operator. Now int star pointer 1 star 2 pointers are integer type pointers. They will hold the memory address of that variables. Okay, so ptr1 by malloc, it has an operator that is called size of. By size of operator, we will be able to find out how much of memory allocated for this malloc operation. So, and that is stored in pointer 1, that is in a pointer. Okay, by calloc operation, see what happened. Size of star ptr1, what do you mean of this size of? Under the malloc function, size of star ptr1, it tells the C language to measure the size of the data at the address. Okay, so already we have studied that size of operator. By that we can find out that how much of memory is allocated. So this size of operator for star ptr1 means, so it tells the C language to measure the size of the data at that address. Which address? Star ptr1, it is a pointer. Okay, so at that star ptr1, how much of data size is there? Okay, so that will be measured by the size of operator. So if you forget the star, if we forget, and simply we write the size of ptr1, so that moment what happened, it will measure the size of the pointer itself, not the data. Okay, if we forget the star at the ptr1, so this size of operator will measure the size of that pointer. So which is the usually 8 bytes that are needed to store a memory address. Okay, so the size of operator cannot measure how much dynamic memory is allocated. When measuring dynamic memory, it only tells you the size of the data type of the memory. So for example, if we reserve space for 5 float values, the size of operator will return 4, which is the number of bytes needed for a single float value. For single float value, generally 4 bytes will be allocated, single float value. Okay, so now dynamic memory, we will use the dynamic memory to improve the students. So above example, students example, how the dynamic memory will be used. So now let us try to understand. So as noted previously, we can't use size of operator to measure how much memory was allocated. Size of operator can't be used here to how much dynamic memory is allocated. So to find out that, we have to calculate that by multiplying the amount of items by the size of the data type. So how many elements are there? That elements multiplying the amount of items with the size of the data type. For one variable, how much of data is there and how many elements are there, by multiplying both, we can simply understand that how much of data allocated. See here what happened. Here star students is what I told you, that whenever we use star, that is what pointer. Int num students, how many number of students are there? 12. Okay, pointer is what? Star students. So number of students 12. So every integer student will hold 4 bytes of data. So how many students are there? 12. 12 into 4, 48. So now what happens? Students is equal to Kellogg function we are using here. Kellogg function has two parameter. One is the two function. Kellogg function has two parameter. One is that size and number of students. Number of students is equal to 12 and size of students. Okay, now if we run this, what happened? Number of students 12. Okay, printf format specifier d, number of students are what? 12 multiplied size of every student 4 bytes, so that is equal to 48 bytes. Understood that? This is very simple to understand. Kellogg function has two. I told you that Kellogg function has two values, two parameters. One is that Kellogg function, it has Kellogg function has two parameters. One is that amount means how many items to be allocated, memory allocated for how many elements, that is what amount. Size, how much of memory to be allocated for each item, each element in bytes. Okay, size of each item. So every element, how much of memory to be allocated for every element. Amount indicates, specifies that how many items are there, how many elements are there. Size, for every element, how much of memory to be allocated, that indicates, specifies the size parameter. Two parameters, Kellogg function. Okay, so according to this, okay, what happened? So in this programming, int star students, it is a pointer. Okay, that pointer will hold that address of the address of students. One more integer, num students, total 12. So number of students 12. Now students is a variable. Here Kellogg function used. Kellogg function has two parameters. One is the number of, means one is that amount means how many elements are there, 12 students are there. Second is what? Size of, for every student how much of size of memory to be allocated. So if we take the printf, here percentage d is a format specifier. D means we will get the answer in integer. So for the compiler, this format specifier indicating that, my dear compiler, now you need to deal with integer type of data. Num students means total students into multiplication size of every student, size of every students. So that is called total 48 bytes. So when we are working with dynamic memory allocation, so we need to check, we should also check for errors and free memory at the end of the program. So then after, stack memory is here. So for completeness, stack memory also it is to be considered. So it is very worth mentioning stack memory. Okay, only dynamic and static memory, that is not adequate understanding of memory management. We need to study about the stack memory. What is stack memory? Okay, stack memory is a type of dynamic memory. It is also part of dynamic memory, which is reserved for variables that are declared inside functions. So any variables declared inside of functions, for them stack memory will be, it is part of dynamic that will be utilized. Variables declared inside of a function use stack memory rather than static memory. So stack memory is part of dynamic memory. So whenever inside of functions variables are used, they will be used stack memory. They will use the dynamic memory, part of your dynamic memory. Okay, so whenever a function is called, this stack memory is allocated for the variables in that function, but stack memory is part of your dynamic memory. When the function returns, the stack memory is freed. When the function returns, so that moment what happened, the stack memory is freed up. So it is very good to be aware of stack memory to be able to handle the memory usage of nested functions, calls and recursion. So recursion that repeats its recursion. In the recursion function recursion, what happens, that same function will be repeated and repeated again. So recursion will be happen here. So recursion that repeats itself too many times may take up too much stack memory. So in the time of recursion, recursion function will be repeated again and again. So too much of stack memory may be utilized. So that moment what happens, it is called stack overflow. Okay, stack memory will be over. When the stack memory will be overflown, so at the time of function recursion, that same function will be repeated again and again. So until a condition is satisfied, so that moment the stack memory may be overflown. Okay. So here is somewhat difference mentioned here. What is the difference between static and dynamic memory allocation? Static memory is allocated at runtime. Static memory. So what is the main difference between static and dynamic memory allocation? Static memory is allocated at runtime. So this statement is wrong. Static memory is allocated at the time of compilation time, and dynamic memory is allocated at compile time. It is wrong. Dynamic memory is allocated at the time of runtime. So first statement is wrong. Second statement, static memory is allocated before the program runs. While dynamic memory allocated at runtime. This is okay. Static memory is allocated before the program runs, means at the time of compilation. This second statement is okay. Third, static memory allocated using malloc. Static memory is allocated using malloc. Malloc and calloc functions both are part of your dynamic memory. So static memory is allocated using malloc. No, it is wrong. While dynamic memory is allocated using calloc. Both calloc and malloc functions part of your dynamic memory. So third statement also wrong. Dynamic memory cannot be freed, while static memory can be freed. Dynamic memory cannot be freed. Okay. So let us see which statement is. I am feeling this one correct answer. Okay, so this fourth statement, dynamic memory cannot be freed. Dynamic memory can be freed. Okay, can be freed because dynamic memory allocation can be done by the programmer by malloc and calloc functions, while static memory can be freed. This fourth statement also wrong. Only second statement is right. So this is part of your class. Now next we will understand access of memory. Under the memory management, I tried to brief you allocate memory. Okay, and in next class I will explain access memory. Okay. And after access, how to access the memory, and reallocation of the memory, deallocation में freeing up of space.